This is a very common question in the higher course. I'll take you through each of the parts for it and show you where you're getting the marks for. So the first bit's asking for the median BD, which is this line here. Part B is asking for the altitude AE, which is this line here. And finally in part C, you're looking to do simultaneous equations to get where these two lines cross at this point right here. What you want to do is first of all break up your question into nice easy segments, remembering the definitions of the terms median and altitude. So let's look at the median for BD first of all. So what does median mean? Well, median means that this line AC is cut in half by this line here. So D is the midpoint of the line AC. So that's the first thing you're going to find out. You're going to find the midpoint of that line. Once you've done that, you'll have this coordinate here. And then because you've got D and you've got B, you can then find the gradient and you can then find the equation of that line. So the only bit that's actually different about this question from National 5 is that you need to find the coordinate of D first of all. The rest of it will be a very similar question to National 5. So let's find the midpoint first of all. We use the formula x1 plus x2 over 2, y1 plus y2 over 2. We substitute the values in. We label them x1, y1, x2, y2 for the coordinate A and for the coordinate C, which come in the question. We then put them into the formula, negative 5 plus negative 3 over 2, negative 12 plus 6 over 2. Now at this point here is where I see probably the most common mistake in this question. A lot of people like to add negative 5 plus negative 12 over 2 and negative 3 plus 6 over 2. And that's incorrect. Remember, you're adding the x coordinates and then you're adding the y coordinates. And remember that difference. So you're not just doing negative 5 plus negative 12, you're instead doing negative 5 plus negative 3. And you're doing negative 12 plus the 6. Okay, so you do that, ends up being negative 8 over 2 and negative 6 over 2, giving you negative 4 and negative 3. And that is your midpoint of the line AC, which we are going to call D because they've given you that in the diagram. Now if you look at the diagram, negative 4, negative 3 seems okay because you'll notice that it's in the negative segments of the diagram. So it's saying it's negative 4 along and 3 down the way. So that makes sense. So that's a fine answer for that. And that's where you're getting your first mark. For the next bit, we're finding the gradient and the equation of the line. This is basically National 5 now. So we've got the coordinate 11, negative 8. We've got the coordinate for D, negative 4, negative 3. We'll label them x1, y1, x2, y2 and substitute into the gradient formula y2 minus y1 over x2 minus x1. We substitute the numbers in. Negative 3 subtract minus 8. Negative 4 subtract 11. We get 5 over negative 15. And that ends up simplifying to be negative 1 over 3. It doesn't matter whether the negative is put really. You could put it in the bottom, the top, or at the left hand side just next to the fraction. Just as long as you remember to have the negative there. And this is your second mark here. So you've got the first mark for your midpoint, second mark for your completed gradient. We then substitute this into the y minus b formula, remembering that you can either select the coordinate b or the coordinate d. The reason I went for b is just because there's only one negative in it, but you could have done either one. So you've got y minus b equals m bracket x minus a, y subtract minus 8 equals negative 1/3 x minus 11. We then want to take into account the fact that we've got a fraction here. So the best way to get rid of that is to multiply by 3. When you multiply by 3, this y becomes 3y. Now you've got two negatives here. Two negatives together become a positive, and 3 times 8 is 24. You then have negative 1 bracket x minus 11. You don't need to write the 1 in. We multiply out that bracket. Negative x becomes negative x, and negative 1 times negative 11 is positive 11. So we have 3y plus 24 equals negative x plus 11. We can then subtract the 24, given 11 minus 24 is equal to negative 13, so 3y equals negative x subtract 13. And that is the equation of the median BD. Some of the numbers involved there are quite tricky, but the process remains the same. So let's look at part B. Part B is altitude of AE. So what do we know about altitude? Altitudes meet at 90 degrees. So this here is going to be a 90-degree angle, which means that you can find the perpendicular gradient to help you out. So we're going to find the gradient of the line CB. We're going to use our factor about perpendicular gradient to get the gradient of the line AE, and this will allow us to find the equation. So it starts off with us finding the gradient of BC. We label the points x1, y1, x2, y2, and we follow the normal approach. We'll do y2 minus y1 over x2 minus x1, 6 subtract minus 8, minus 3 subtract 11. 14 over minus 14 gives us negative 1. So that is our first mark in this question, and we have found that the gradient of this line CB is negative 1. Now, we want to find the perpendicular gradient because this isn't the line I want. I want this line AE. I know that this is negative 1, so therefore I can find the perpendicular gradient using my fact that m1 times m2 is negative 1. So that means that the perpendicular gradient is going to be 1. Now what I've done is I've included the perpendicular gradient symbol equals 1, and I've also included the gradient of AE equals 1. Whatever you prefer to write is okay. So we've worked out that the gradient of this line is 1 because this one's negative 1 and we know that this one's perpendicular. So we've found that this gradient is 1. Now the thing is, I could either substitute in the coordinate for E or the coordinate for A, but the problem I've got here is I don't know the coordinate E here. Now a common mistake is for people to substitute in the midpoint, but altitudes are not necessarily in the middle. So we can't assume that E is the midpoint. So what we've got to do is we've got to sub in our A coordinate into y minus b. So it'll be y minus b equals m bracket x minus a. We label negative 5, negative 12 as AB. Y subtract minus 12 equals 1 bracket x subtract minus 5. Now you don't need to put the 1 here at all. We change these double negatives into positives. Y plus 12 equals 1 bracket x plus 5. Now you really don't need to write the 1 in here. I'm just showing you for this example you can get rid of it. And we know that the 1 times x is x, 1 times 5 is 5. So 1 plus 12 equals x plus 5. And then we take away 12, gives us x minus 7. So y equals x minus 7. So I'm only putting the 1 in here just to show you where I'm getting it from because it's related to the gradient here. You could immediately just write x minus 5 and x plus 5. Okay, so when you're doing these examples, substitute in your gradient for perpendicular and your value for a, which is AB here, negative 5 minus 12, put it all through, and there you've got y equals x minus 7 is your final answer for part B. But once you've got that, it's now a case of us finishing off the question looking at part C. Part C is asking us to find the point of intersection. So essentially what's going to happen is we're going to use our answer for A, we're going to use our answer for B, and we're going to do simultaneous equations. What I'm going to do is I'm going to take you through 2 separate methods to do this. You can pick the one that works best for you or the one that your teacher does with you. So let's look at this then. We'll do method 1. And that's me going to rearrange into the familiar National 5 form and then do elimination. So in National 5, a lot of you would take these 2 simultaneous equations and you would want the letters on one side and the numbers on the other side. So what we're going to do here is, I don't like the fact negative x is on the right hand side, so I can add it on, make it positive. So 3y plus x equals negative 13. And on this side, this positive x, I can move it to the other side, make it negative. So I get y minus x equals minus 7. Essentially, I'm just making it so that I've got the y and the x both on the left-hand side, as you would see in National 5. I put those 2 together. 3y plus x equals negative 13. And y subtract x equals negative 7. And I label them 1 and 2. Now, I want to eliminate. and I look at the x terms and they're both 1x. One's positive 1x, one's negative 1x. So that's fine. But because the signs are different, I can add them. So different signs, so I can add them. We've got 3y plus y is 4y. X plus negative x will be 0. That will disappear. And negative 13 plus negative 7 is going to go further down the number line to negative 20. I divide by 4 and that gives me y equals negative 5. Now, a common mistake is just to forget to do anything else and leave it as y equals negative 5, but we need to find the x coordinate. So what I do is I can substitute in y equals negative 5 into any of the equations above. I'm going to go for this one here, y equals x negative 7, because it's just a bit easier to work with. So I've got y equals x take away 7. I substitute in y equals negative 5. So negative 5 will replace y equals x minus 7. I want x on its own, so I'm going to add on 7 from this side. So negative 5 plus 7 equals positive 2. And what that's going to mean is my final answer is going to be 2, negative 5. That will be my point of intersection because I've worked out that x equals 2. I've worked out that y equals negative 5, and I've got to put them together to get my point of intersection. A lot of people forget to put it as a coordinate. Make sure you do that because it is asking for the coordinates in the question. That is one way that you could do this. I'll show you a second method now that a lot of people prefer to use, and that is to form an equation and solve like you would do from first and second year. So we have 3y equals negative x subtract 13, and we've got y equals x minus 7. Now, if these were both equal, I could set them equal and solve it, but they're not because 3y is different from y. So what I could do is I could multiply by 3 here, so we can get y to be 3y, so it matches equation 1. So if we make this 3y, it will match up with this one, and then we can set the two of them equal. So if I keep this one the same, 3y equals negative x subtract 13, what I can do is I can multiply this by 3, and remember I'll multiply everything by 3, so it'll be 3y equals 3x subtract 21, because y times 3 is 3y, x times 3 is 3x, and 7 times 3 is 21. Then you're saying that this is the same as this. 3y equals, they match up. So if 3y equals negative x minus 13 and 3y equals 3x negative 21, I can then bring them together. So negative x subtract 13 equals 3x subtract 21. Then I can say, well, let's solve it. I don't like the fact it's negative x. We'll deal with the smaller x's first. So I'm going to add on x. So if I add x to this side, it will keep negative 13 in the left-hand side. But 3x plus 1x is 4x. And it will keep the negative 21 here. Then I can deal with the negative 21. I'll add it on to the other side. So if I add on 21, it will leave me with 4x on the right-hand side. And negative 13 plus 21 is 8. Then 8 equals 4x, so x equals 2. Now, because x equals 2, I can then find my y coordinate. And again, you can pick any of the equations you've got. I'm personally going to pick this one here because it's the easiest to work with. So y equals x minus 7. I substitute in x equals 2. Y equals 2 minus 7. So y equals negative 5. And therefore, my point of intersection is 2, negative 5. And it's the same answer as I did in the previous method. So either of those two methods are perfectly acceptable. There may be more methods that you've seen and you can use, but these are just two that do work for you. Now, any of them are fine. If you have any questions, please just comment below on the page, and I'll produce more of these videos on all the different topics.